In this podcast, I will answer question 2. Question 2 is a proof, and asked us to prove that if the coset of A and the coset of B here are equal, that is if and only if A is congruent to B modulo that ideal. Okay. Because this is an if and only if, we have to prove it in both directions. So we are going to start by proving that the two cosets are equal implies that A is congruent to B modulo I. So let's define them. A plus I is the set of all elements alpha, such that A minus alpha is in I. It's in the ideal. And the coset of B is the set of elements, call them beta, such that B minus beta is in I. Okay? If A plus I equals B plus I, then for some alpha and beta, A minus alpha is equal to B minus beta. They must be because of the set of elements. Okay? This implies that A minus B is equal to some alpha minus beta. All in I, because it's an additive subgroup. So all in I, which implies that A minus B in I, which implies that A congruent to B modulo I. Okay. Now, because it's an if and only if, we'll attempt to show the other direction, that if A is congruent to B modulo I, that implies that A plus I is equal to B plus I, or the two cosets are equal. Okay. For this, we are going to recall that A modulo congruent to B modulo I implies that A minus B in I. And use that fact. Okay? We're going to imagine two elements, alpha and beta, such that alpha minus beta is also in I. Okay? And if that is the case, by theorem 5.1, we can write that A minus alpha is congruent to B minus beta modulo I. Now, if we consider what this looks like, well, this looks like the two cosets, just on face value. And actually, hence, we can write that A minus alpha minus B minus beta is in I. And this means, because it's an additive subgroup, that they must be in the same ideal. And hence, the two cosets are equal. Because of this fact, because they are one element. So A minus alpha must be equal to some element, and B minus beta must be equal to some element. Now, A minus alpha is in A plus I, B minus beta is in B plus I, and hence they are subsets of each other, which implies they are equal.